Okay. Okay, so in coordinate geometry, before I start with the one very important formula, there is one very important formula in coordinate geometry, and that is called as the distance formula. Okay, now before I start with this formula, I just want to revise a few concepts. And, first concept I would like to revise is point. What is a point? In a graph, okay, when I say a point in graph, what do you mean by a point? How will a point look like? So for example, if you have the x-axis and the y-axis. So I'll just the axis. So this is the x-axis and this is the y-axis. In a graph, how will a point look like? Can you tell me? Suppose I want to take point A anywhere on this graph. So
it'll either be on x-axis or it'll be on y-axis.
Yes, correct. So it is of the form x comma y. Any point A will be of the form x comma y. So where x is a coordinate that will lie on the x-axis and y will be the coordinate that will lie on the y-axis. So for example, if I say 1, 2, okay, suppose this is point B, 1, 2. So how will you plot it? So this one.
So 1 will be on x, correct, and 2 will be on y.
Correct. So this is 1, and suppose if this is 2. So this point that is connecting both 1 on the y-axis, sorry, 1 on the x-axis and 2 on the y-axis will be your point P. So in general, a point, we denote it by any capital letter. It is an ordered pair, x comma y. Okay, it's a pair with x comma y. The x comes from the x-axis. So this is called, the first component will be the x coordinate and the second component or the second number will be the y coordinate. Okay, so now knowing what is a point, we'll come to distance formula. What is distance formula? Our entire chapter of coordinate geometry is based on this formula. That is a distance formula. As the name suggests, it says distance. That means this is used to calculate distance between 2 points. This formula is used to calculate distance between 2 points. Distance between 2 points. Okay, so is the general idea clear? What will distance formula be? I'll explain the formula in our next thing. Okay, distance formula, it will calculate distance between 2 points. Okay, I'll just open the textbook. If you look at this figure, we have, look at the point A, which has the coordinate x1, y1, and look at the point P that has the coordinate x2, y2. Now we are interested in finding the distance between A and B. So if you look at the graph, this distance. Okay, this distance A and B.
Yes.
So distance between 2 points. Okay, just ignore the point D, look only point A and point B. Now to find the distance between the 2 points, we will use this famous formula that is called as a distance formula. So I'll write distance between A and B is denoted as DAB. Okay, so this means distance between point A and point B. And the formula is under root of x2 minus x1 the whole square plus y2 minus y1 the whole square. If this formula, once you use this formula and calculate it, simplify the sum, then answer that you get will be distance between the 2 points, that is point A and B. So this distance you will get by using this formula. Okay, so I'll repeat the formula. The formula is distance AB is equal to under root, okay, the whole square root into x2 minus x1 the whole square plus y2 minus y1 the whole square. And now by now you should be knowing where x1, y1 and x2, y2 where it comes from. So x1, y1 are the coordinates of A, x2, y2 are the coordinates of B. Is this clear up to here? Distance formula.
Yes. Yes.
Okay, write down the distance formula. Once you're done writing, just let me know. So our entire chapter is based on this very basic and very important formula. Okay, can I do one example sum now?
Just a minute.
Yeah.
It's done.
I'll do an example sum which is there in the textbook itself. We'll understand it first and then you write it. Okay, so this the first example sum is. And then we'll move on to the exercise. So it says,
Okay.
find the distance okay, so this sum says find the distance between the point P. So P has coordinates -1, 1 and Q, which has coordinates 5, -7. Okay, we have to find distance between these 2 points. Okay, let's see.
Yes.
Let's start with the solution. Okay, so first you write the coordinates that is given. P has coordinates -1, 1 and Q that has the coordinates 5, -7. Okay, so now the first point P, you take it to be having coordinates x1, y1. And the second point, that is point Q, you take those coordinates to be x2, y2. So from here, we know that x1 will be, what will be x1? Can you tell me what will be x1?
-1.
Correct, -1. And y1 will be 1.
1.
Similarly, x2 will be 5 and y2 will be -7. Okay, first you pay attention, later on, once you understand, then I'll give time for you to write. Okay, now we'll use distance formula. So whenever you're using the formula, make sure that you write it. So I'll write here by distance formula. So by distance formula, now we are finding distance between P and Q. So I'll write D of P and Q is equal to, write the formula first. So equal to x2 minus x1 the whole square plus y2 minus y1 the whole square. Now we already know what is x2, what is x1, y2 and y1. So now we'll just substitute the values. Okay, now we just have to substitute the values. Okay, now you tell me what is x2?
5.
5 minus x1.
-1.
So here write it in bracket, -1 the whole square plus y2 is
-7.
-7 minus y1. How much is y1?
1.
1 the whole square. Now we need to simplify it. Okay, look at the first term here. This is 5 minus of -1. So what will this change to?
Addition?
Yes, correct. So it becomes 5 plus 1 the whole square plus -7 minus 1 the whole square. Now we need to simplify it more further. So this becomes under root 5 plus 1, that is 6.
6 square.
The whole square. What about -7 minus 1?
Plus.
Yeah, you'll add
addition.
it. So what do you get?
8.
8. But what sign will you put?
-8.
Yeah, -8. Okay, because both are negative. So the answer will also have a negative sign. Or in other words, you put sign of the greater number, and we know 7 is greater, and the sign for the number 7 is minus. That is why minus.
So -8.
-8 the whole square. Now we need to just take the square. What is the square of 6?
36.
36. Plus, what is the square of -8?
-64.
Okay, one mistake you did is square of a negative number is always positive. Okay,
So
whenever you
64.
take, yeah, so just 64. Okay, I'll just write it as a note here. Square of a negative number is always positive. Okay, negative, this minus VE means negative, okay?
Yes,
square of a negative number is always positive. Square of a negative number is always positive. So square of -8 is plus 64. Okay, now we need to just add it. 36 plus 64. How much is this?
100?
Yeah, correct. 100. And last is you need to take the square root of 100. So this is also easy. What is the square root of 100?
50?
No, it's not 50. See, what is the square of 2? What is the square of 2?
4.
4. So what will be the square root of 4?
2.
2. Okay. So similarly, what is the square of 10?
100.
100. So what will be square root of 100?
Okay, 10.
10. So this is 10. So distance between P and Q is 10 units. This is my final answer. Okay, I want you to now go through the sum from start to end and then write it down. I'll just zoom out, okay? Is the sum visible for you from the start to end?
Yes.
Okay. Are you on your mobile or on the laptop?
No, I'm on the laptop.
Laptop. Okay, I think then you can zoom also on the laptop.
Yeah.
There'll be an option up for you to zoom in case you cannot see. Okay, go through the sum from start to end and then write it down. Once you're done, let me know.
Yes.
Okay, so for example, here we had to find out the square root of 100. Yes, we had to find out the square root of 100. So first what you do is you find out all the prime factors of 100. Do you know this method, prime factors to find out? You find out all the prime factors.
No,
So
no.
2 5s are 10, then 0. So 2 2s are 4, so 2 25s are 50. Then 5 5s are 25, 5 1s are 5. Do you know these are all prime factors?
No, I did not know
No,
this.
you don't know? Okay, okay. So I'll show you this method and then we'll go for the exercise sums. So first what you do is you write here 100 and okay. You see the least number, the smallest number that is divisible by 100. That means the smallest number with which you can divide 100. So the smallest possible number is 2.
2.
2. So if you divide 100 by 2, what will be your answer?
50.
50. So that's why I write here 50. So 2. So this is basically I'm doing division. So 2 5s are 10 and here 0. So you multiply these two, 2 into 50, you will get this 100 back. Okay.
Okay.
Okay. Now again, if you see 50 is again divisible by 2. How? So
Yes,
2,
25.
yeah, 2 2s are 4, here 1 borrowed, so this becomes 10. So 2 5s are 10. Next, if you
Yes.
see 25 is not divisible by 2 and the only possible number is
5.
5. So here I have 5, 5s are 25. And last is
Yeah.
5 here. So 5 you can only divide by 5.
5.
So you have 5 ones are 5. So when you have 1 here, you stop. Okay, when
Okay.
you have 1 here, you stop. Now you see here we have a pair of 2 and here we have a pair of 5. So finally you write
Yes.
it's 2 into 5, which is 10, and the answer
10.
that we got was also 10 here. So the square root of
Oh,
100
okay.
is 10. This is a prime factor method to find out the square root. Is this clear? We'll do plenty
Yes.
of more sums on these.
Okay. Got it.
I'll move to the exercise. We'll do same type of sums from the exercise. So exercise 5.1. Exercise 5.1, we'll do the first question. So the first question, entire is of the same type. So we have to find distance between each of the following points. And in this, the first one will take, that is A, 2, 3, and B, that is 4, 1. So we have to find distance between each of the following pair of points. Exactly same way. So I'll solve this. We'll start with the solution. The 2 points are, first is A, 2, 3, and second is B, that is 4, 1. So the first point you take it to be x1, y1, and second point you take it to be x2, y2. Okay, so now we know x1 will be 2, y1 will be 3, x2 will be 4, and
y2 will be 1.
y2 will be 1. Now we are using which formula?
Distance formula.
Okay, see, make a point that you write it. So by distance formula, and write the formula first. Whenever you're using the formula, make sure that you write it. The distance AB equal to under root of x2 minus x1 the whole square plus y2 minus y1 the whole square. Now we need to just substitute the values exactly same way. So this would be x2 is 4 minus x1 is 2 the whole square plus y2 is 1 minus y1 is 3 the whole square. Okay. How much is 4 minus 2?
2.
This becomes 2 square. What about 1 minus 3? 1 minus 3. You will do the subtraction. So how much is 1 minus 3?
2.
2. But you put sign of the greater number. What is the sign of the greater number?
Minus 2.
So this becomes minus 2 the whole square. Okay. What is the square of 2?
4.
What about minus 2?
4.
Also 4. Correct. So this becomes 4 plus 4. How much is 4 plus 4?
8.
8. Okay, so the distance between AB is root of 8. You can leave this as it is, or we can simplify this further. Okay, how? Just look at the way how we will simplify. So 8, you can write it as 2 into 4. Yes or no?
Yes.
Okay, I can leave the sum further, but with this, we can simplify. You can leave it here, you can stop here, but it's possible to simplify. So let's simplify. So 8, you can write it as 2 into 4. So this becomes under root of 2 into 4. Now, since there is a multiplication sign, okay, pay attention to the words that I'm using. So since there is a multiplication sign here, we can separate the root for 2 and 4. Okay, so you separate the root, put the root for 2 into, and then you put the root for 4. Is this clear? What I did here?
Yes.
You can separate the root because there is a multiplication sign. So the root sign have given for 2 and the root sign have given for 4. Now, you know the root of 4. What is root 4?
2.
2. So instead of root 4, just write 2. This and this, I'll write it as 2. So this, we can just rearrange little bit. This number, we can write it in front of the root. So this becomes 2 root 2. Is this clear?
Okay.
Okay. I'll just rearrange it at this 2. We have written it in front of the root.
So the 2 in the front will not be in the bracket?
No, no need to write in the bracket. Actually, here also there is no need to write in the bracket, just for you to understand I wrote it. There's no need to write. Or you can directly come up to this step here, this last step. 2 root 2. Is this clear?
Yes.
So distance AB is
2 root 2.
2 root 2. Or you can stop here also. There is no problem if you stop here. But since it is possible to simplify, we will simplify. So distance AB is 2 root 2. Is this sum clear?
Yes.
So I hope you can see the sum from start to end.
Yeah.
Is it visible, clear enough?
Yes, yes.
Okay, write it down. We'll do for the second sum. We'll go for the second sum.
Yes.
P, which has the coordinates -5, 7, and Q that has the coordinates -1, 3. Okay, I'll solve this one as well. In the next one, I'll give you. Okay, so P has coordinates 5, 7, and Q having coordinates -1, 3. So this is x1, y1, exactly same way, x2, y2. Okay, so x1 will be -5, y1 will be 7, x2 will be -1, y2 will be 3. So we'll say by using distance formula,
Yes.
distance between PQ is equal to, so I'll write a formula first. So this is x2 minus x1 the whole square plus y2 minus y1 the whole square. Next is to substitute the values. So can you tell me the values? X2, x1, y2,
-1.
-1 minus of
Minus
x1 is, look here, x1 is
-5.
-5. So this becomes -1 minus of -5 the whole square.
Yes.
Plus y2 is
3.
here 3 minus y1 is
7.
7. So 3 minus 7 the whole square. Okay, now pay attention here carefully to this position, this part, first term. It's -1 minus of -7. So how will we rewrite this? So -1 minus into minus will become
Plus, but
plus.
bigger number sign.
+5. Okay, here, look here. This is minus and this is also minus. So minus into minus becomes plus. So that's why this is -1 plus 5. Close the bracket, the whole square. Plus this I'll write as it is 3 minus 7, the whole square. Now in the next step, we'll do the addition or subtraction, whatever it is. So now this is -1 plus 5. So -1 plus 5, what do you do? Addition or subtraction?
Subtraction.
Subtraction, correct. So subtracted, how much will you get?
4.
4. And sign?
Plus.
Plus. So I'll just write here, just 4. So this becomes 4 square plus 3 minus 7. So how much is 3 minus 7?
4.
4. But sign of the greater number? -4. So this will become -4 the whole square. Now in the next step, we need to take the square. So what is square of 4?
16.
And square of -4?
16.
16. So you have the 16 plus 16. So how much is 16 plus 16? Can you do it? 16 plus 16, how much is it?
32.
32, correct. So this is 32. So you have square root of 32. So you can stop here. You can say that this is the final answer, but 32 can be reduced further. We can reduce it. So we will reduce it further.
16
so yeah, correct. 16 to. So this I'll write it as 16 into 2. And then you separate exactly same way. So you separate the root. So root 16 into root 2. Now you know what is square root of 16?
8.
No.
4.
4, correct. So this becomes 4 and then this root 2 as it is. So distance PQ is 4 root 2. So this is your final answer, 4 root 2. Is this some clear?
Yes.
Okay, so just to know. Okay. Write it down. Let me know once when you finish writing. Okay, so this will be our x1, y1, and this will be our x2, y2. So this name x1 is 0, y1 is -3, x2 is 0, and y2 is 5 upon 2. The same way, we'll use a distance formula. So by distance formula, we have distance RS equal to x2 minus x1 the whole square plus y2 minus y1 the whole square. Now we'll just substitute all of the values. So here we'll have x2, that is, what is x2?
0.
0. So you have 0 minus x1 is also 0.
0.
So 0 minus 0 the whole square plus y2. y2 is the fraction.
5 upon 2.
5 upon 2 minus y1 is
-3.
put it in the bracket. So it becomes -3. So the whole square. Okay, so you have your 0 minus 0. So we know 0 minus 0 is 0 itself. And 0 square will also be 0. Plus 5 upon 2. Okay, now what will happen here? Minus into minus will become
Plus.
plus. Correct. So this becomes 5 upon 2 plus 3 the whole square. Okay, now in our next step, we know square of 0 will become 0 and 0 plus any number is that number itself. So I can skip this 0 in the next step. So there's no need to write it. So I'll write here 5 upon 2 plus 3 the whole square directly. Is this step clear?
Yes.
Okay. Now here we have a fraction plus number. So what will we do here? We'll do cross multiplication. Do you know how to add a fraction
Yes,
and a... Okay. Yeah. So we'll do cross multiplication. So if you see here, it is
3
just
upon 1.
3. Yeah, correct. 3 upon 1. So this becomes 5 into 1, that is 1. Plus. So first this, then this way. So 3 into 2 will be
6.
6 upon what will come in the denominator?
2.
2 into 1, that is 2 itself. So you have 5 plus 6 upon 2 and then the whole square. Is this clear?
Yes.
Okay. 5 plus 6 is 11 upon 2 the whole square.
Yes.
Okay. Now in the next step, what you can do is you can take the square. You'll have to take the square. So what is, okay. Before that, okay, I'll do it here itself. You can separate the square. You can give the square for the numerator and the square for the denominator. This becomes 11 square upon 2 square. Correct?
Yes.
Okay. Now you can avoid this step, this one step you can avoid. And I will, okay, I'll complete this first and then I'll tell you the shortcut way of identifying.
Okay.
What is the square of 11?
22.
No. Go 1. 11 multiplied by 11. So it's
121.
Like, yeah, correct. So 121. And what is the square of 2?
4.
4. Now in this step, we can separate the root for the numerator and the denominator. Okay, there is a division. So in division also, it is possible to separate the root for the numerator and the denominator. If you remember, in the previous sum, there was multiplication. And in multiplication, when there is a multiplication sign, that time also it is possible to separate the root. And when there is division sign, that time also it is possible to separate the root. If there is addition and subtraction sign, then you cannot separate the root. Okay, keep these points in mind. When there is addition or subtraction sign, you cannot separate the root. But if it is multiplication and division, then you can separate the root. So here I will separate the root. So root 121 upon root of 4. Now, can you tell me what is root of 121?
11.
11, correct. And what is root of 4? 2.
2.
So you have 11 upon 2. So distance between RS is 11 upon 2. You can write it in decimal also, or you can leave it in fraction as well. So I'll leave it in fraction. So 11 upon 2. Now there is one shortcut way of we can avoid this steps. So this step we can avoid. This step. Okay, this step can be avoided. How it can be avoided, I'll tell you that. Look here. So we got up to this step. I'll take it here. If you see up to this step, you got distance RS. Okay, look at this step. Okay, up to here, you got it under root of 11 upon 2 the whole square. Yes, up to here this was clear, right?
Yes.
Okay, now at this step, what you can do is this square root and this square sign for the fraction, you can cancel it. Okay, but you don't show the cancelling. You just assume it in your mind in that it gets neutralized, it cancels each other. The square and the square root. Okay, there is no need to write and show it. You can just assume that it gets cancelled. And whatever is inside it will remain as it is. So inside we had 11 upon 2. So 11 upon 2 as it is. So distance between RS is 11 upon 2. Is this clear what I did here?
Yes.
Yes or no? I couldn't hear you. Can you just repeat? Did you understand this, what I did here?
Yes, I understood.
Okay. Okay. So, but when you're writing, you don't show this cancellation. Okay, this cancellation you don't show. You directly come to this step. Clear now? So see, this is avoiding us these steps. These so many steps are getting avoided just by the simpler reasoning. That is, the square root and the square gets neutralized, or in simple words, square root and square gets cancelled out. And we are left with 11 upon 2. So the answer, distance between R and S is 11 upon 2. Okay, you can write it down now. Let me know once you finish writing.
Yes.
Yeah, okay. So when will points be collinear? I'll just write the definition. If the points if the points lie on the same line, then they are called as collinear. If the points lie on the same line, then the points are called collinear points. Are called collinear. Okay, so look for example. Okay. For example, suppose if you see point A and point B. Now these 2 points, it is possible to join these 2 points with a straight line. It's possible to join these points with a straight line. That means these 2 points lie on the straight line. So I'll say point A and B are collinear. Okay, point A and B are collinear.
Okay.
Similarly, look at this example. A, B, and C. Are these 3 points collinear?
Yes.
Yes, they will be collinear because you can join it. All of the 3 points will lie on a same line. So it is collinear. Okay. So this is also collinear. So A, B, and C are collinear. Now, can you tell me, will this be collinear? P, Q, and R. Will P, Q, and R be collinear?
If we draw 2 lines, then they'll be collinear.
No, but all 3 points should be on the same line. So is it possible for all of the 3 points to be on the? It's not possible. So P, Q, and R are not collinear. Okay, so now you have understood the definition of collinear and non-collinear. So if they lie on the straight line, same straight line, then they are collinear. If they do not lie on the straight line, on the same straight line, then they are not collinear. So our second part of this exercise, if you see, it is determine whether the following points are collinear or not. That we will do in our next class. Okay, I'll stop here.
Okay.
So in